Let's go into pre-calculus next year. We dedicate basically the first month just to this that you're going to be learning in this lesson. So there's three key things we're really going to be looking at. So what you could see here, this is called a vertical asymptote right here. So this one right here at x equals 4, this is called a vertical asymptote. And what's going on here is this acts like a wall. The function hits this wall and it either blows up to infinity, or from the other side you can see it's going down to negative infinity. And that's what a vertical asymptote does. They could both be approaching the same infinity, but point is, you see the dashed line, that's a vertical asymptote. We're going to take a look at when we run into this situation algebraically. This one's called a jump. We're not worried about that yet, not this year anyways. The next thing is zeros. We should already know about zeros, so let me just go ahead and show you. There's a couple of zeros on this graph. So this right here would be a 0. Why? Because it's crossing the x-axis, so we call those a 0. And then the last one is the removable discontinuity. Different than the jump. The jump is over there. This is a removable. And the reason why this removable discontinuity is realize the graph is going along, doing its own thing, minding its own business, and then boom, at this point it has been removed and nothing is there, and then it continues on minding its own business. So that's a removable, this time at x equals -3. So we're going to take a look at what causes these three things. What causes the zeros, what causes the vertical asymptotes, and what causes the removable discontinuities on the graph. So like I said, next year, pre-calculus, boom, this is a huge topic. AP calculus, huge topic. For us though, we're introducing the three ideas. It's a good time to do this. So when do we have a 0? So we're dealing with rational functions. So if you have a 0 on top, and then you have a no 0 on the bottom. Let's put not a 0. You'll see right now. So let me just show an example. So an example, and we'll do it in factored form. So if we have x minus 2, x plus 3, over x plus 3, x minus 7. I'll use the same example for all of them. So let's look at x minus 2. Notice x minus 2. What would cause this? X equals 2 would be a 0 on the top. Or in the numerator, but not in the bottom. Notice if we plug in a 2 to the bottom, that's not going to cause a 0, not going to cause any issues on the bottom, only with the top. So if you have the top to be a 0, but not on the bottom, then that's just going to be a 0. Let me move some stuff over. Okay, so let's talk about the removable. The removable is when you have, that's interesting, I didn't mean for that to turn red. So removable is when you have a 0 on the top and the bottom. The same factor has the 0. So for example, and it'll be the same example, if you have x minus 2, x plus 3 over x plus 3 times x minus 7. We're really looking for the same factor here. So x plus 3 and x plus 3. Notice those are the same factor there. So x equals -3 would cause a 0 on the top and the bottom. This would be a removable discontinuity. This would be the situation we have that. So if you have a 0, basically that factor is going to cancel because x plus 3 are both the same. They would cancel out. That would cause the removable discontinuity. And then last one, vertical asymptote, you can guess, is going to be where you have the 0 on the bottom and not a 0 on the top. For that particular number anyways. Okay, so for example, same example, and you can guess if you look at the same thing that we've been dealing with, x minus 2, x plus 3 over x plus 3, x minus 7. We're going to focus on this x minus 7. Notice the 7, x equals 7, would cause a 0 on the bottom, but no 0 on the top. So this would be a vertical asymptote. but 7 wouldn't cause any issues on the top, wouldn't cause any zeros on the top. So once again, if you have a 0 on the top but not the bottom, that's just a 0, that's an x-intercept. You can look at the graph above. And then removable is when there's a 0 with both on the top and the bottom for that particular number. And then vertical asymptotes when you have a 0 on the bottom but not the top.